Okay, so it's day 1 of our mock STAAR review, and we're starting out with category 1, which is, let's see, it's theoretical and experimental probability of simple and compound events. So just want to remind you, so theoretical probability is what should happen. So if you flip a coin 10 times, you should get heads 5 times because there's a 50-50 chance. Now, experimental is exactly what it sounds like. You're actually doing an experiment and using what happens in the experiment to predict future outcomes. So with probability, we generally do what we are looking for over the total. So if we're looking for the probability of heads, it would be the number of heads, which there's 1 head on a coin, over a total of 2 sides. Or maybe probability of, let's say, even numbers on a fair number cube over a total. So even numbers would be 2, 4, or 6. So there's 3 options out of 6. So that would be 1/2 as well. So let's go ahead and get started. So question 1, a bag contains 4 sour apple and 3 watermelon candies. 1 piece of candy is chosen at random and returned to the bag. Then a second piece of candy is chosen. What is the probability that both pieces will be sour apple? So let me go through and analyze. So we have 4 sour apple, 3 watermelon, 1 piece of candy is chosen and returned. That's very important. And a second piece is chosen. What is the probability? Let me turn that into a circle. That both pieces are sour apple. So the probability of sour apple, it's going to be how many sour apples? So there's 4 sour apple out of a total of 7 candies. 4 plus 3 out of 7 candies. So that's the first poll. The second poll, again, they want to know if it's sour apple. And it is returned. So that's going to be another 4 out of 7. So with compound events, which means that you're looking at one event happening and then another, you're going to multiply your probabilities. So 4 over 7 times 4 over 7, because neither of these could be simplified. And one thing to think about, your total, if he had taken the candy out and eaten it, our total would have been, both the sour apple would have changed because he would have eaten a sour apple, so we would have only had 3 left. And the total number of candies would have changed because 1 was eaten. We would have only had 6 left. But since it was returned, we're able to keep our probability. So 4 times 4 is 16. 7 times 7 is 49. Can either of those be simplified? No, they don't really have any common factors. So that's our answer. So number 1 is C. Now let's take a look at number 2. A bag of marbles has 7 red marbles, a white marble, 7 red marbles, 4 white marbles, 3 blue marbles, and 1 black marble. So which color is the most likely outcome for pulling a marble out of the bag? So no matter which one we pull out, there will be a total of 7 plus 4 is 11, plus 3 is 14, plus 1 is 15. So whatever it is going to be out of 15. So which one is most likely is going to be the most frequent, or the color that is in there the most. So red. So a red marble is going to be our most likely outcome. There's only 1 black, so that's the least likely. there's 3 blue marbles, so that would be the second least likely. And then 4 white, that's next, so that's the second most likely. And then the most likely is the red because it's 7 out of 15. The white is 4 out of 15. The black is 1 out of 15. And the blue is 3 out of 15. Okay, so moving on to the next problem. Question 3, there's 8 girls in dance class. The girls are represented in the diagrams below by the numbers 1 through 8. If each girl needs a dance partner, which list shows all the possible combinations of the girls in dance? So first of all, let's write it out and think about it. So girl 1, 2, 3, 4, 5, 6, 7, 8. So girl 1, if we start with her, she could dance with any of these people down here. So she could dance with number 2, 3, 4, 5, 6, 7, 8. So 2 through 8. Now number 2 could dance with anyone below it because the option of dancing with number 1 has already been completed with number 1. So it's going to start at 3 and go all the way down to 8. And then number 3, it's already listed with 1 and 2, so now we start with number 4, anyone after it, and that goes all the way down to 8. So knowing that A has very limited options, and 1 dances with 2 and 2 dances with 3, well, they can't dance with 2 people at once, so A's gone. C only shows options for girl 1. And let's see, B is very limited as well. So D most matches the diagram I drew. So that's your correct answer. All right, so now we're ready to go on to number 4. With number 4, Sam spins the spinner below 120 times. How many times can Sam expect to land on blue? So blue is what we're looking for. I'm going to use blue here. So we are looking for this piece right here. And blue's only listed once. So the probability on the spinner of getting blue is 1 out of 1, 2, 3, 4, 5 total options. So the probability of blue is 1 out of 5. Now, if they spin it 120 times, what do you guys think we need to use to find this? This kind of sounds like a part over whole type situation, right? So that means we need to use a proportion. So 1 out of 5 equals how many out of 120? So we're going to do our cross product. So 5x equals 120. Going to go over here and do my division because I need to isolate x. That means I divide by 5. Divide by 5. This cancels out. So I have x over here. I need to divide to find it this side. Let's see. 2 times 5 is 10. I'm going to subtract. 2 minus 0 is 2. 1 minus 1 is 0. Pull down this 0 here. 5 times 4 equals 20. And I subtract, and that's it. So x is 24. So what that means is that for the 120 times that they spin it, we can expect for it to land on blue 24 times. So it's D. Good job, guys.